My name is Ziad Zahir, and this is my presentation on the 3 technology tools we'll be using for the AP Physics 1 Rotational Motion Unit Plan. The first technology tool is called Classflow, which is a dynamic formative assessment platform essential for distance learning. Teachers can log in through classflow.com and students can log in through classflow.com/student, and students do not need an account. This is the login page, and once you log in, you'll see that you can instantly access a whiteboard where you can type questions. There are many types of responses you can ask for, whether it's a multiple choice, a written response where they can use their stylus, or just a simple text. As soon as you push out a question, text question, on the student end, the students will see the question where they'll have a chance to respond to the question. Once they submit their answers, the answers are sent to the teacher end with the name of the student and an interactive placard that you can use to sort and check for understanding. Okay. All right. The next tool will be essential for our rotational motion study, which is called PhyPhox, a free application on both iOS and Android. This platform allows you to access your accelerometers that are already within your phone to gather valuable data in doing homegrown experiments. It is important to understand how the 3 XYZ axes work, as the accelerometer can measure acceleration in all 3 axes. Okay. Once you start recording, just by hitting the triangle, the play button, you'll see that all acceleration data is there in all 3 axes. Okay. This plus sign will turn this play will turn into a pause, which you can stop data collection. You can also pinch to zoom and look at your graphs at a much closer view. Okay. And if you want to export your data, you just click on this triple dot button here at the top. You can export it as a CSV, which you can then import into Excel. All right. Now, Excel may be a platform you're familiar with, but we'll be using some more advanced features within Excel to analyze our data that we can export from PhyPhox. Okay. I've already loaded up an Excel file with some example data shown here that has time data and velocity data back to back. Okay. If you want to create a graph within Excel, typically we use scatter plots in physics. All you have to do is highlight everything and insert and scatter plot, which is the one with a bunch of dots. We'll choose the first one. Okay. Typically, we don't like connecting dot to dots as we try to analyze the patterns from within the data set. Okay. Notice how I've highlighted only a certain selection of the data and not going over, so I have the option of choosing which data set or how much data I want to graph within my plot. Excel has many advanced features and options. As soon as you click on the graph, there's this green plus sign, which allows you to access all of these features, such as axis titles, okay, where you can label your axes. In this case, the x-axis with this time axis, and typically we also include the unit of measurement. But more importantly, what we would like to do is model the function based on our data. Typically, when your sensors will just give you raw data like this, you can insert a trend line. Now, if it's a the linear trend line, which is the default function, we'll just draw a trend line here. But instead, what we want to do is go to more options by clicking on the green arrow. Okay, and this will allow us to show the equation on screen. Sometimes the data set is not linear, and therefore you may not want to use a linear trend. So let's go and get rid of this and go back to our trend lines. More options. Okay. I see that it's more like a curve, so I'll go ahead and use a polynomial trend. Order 2, which means it's the power of 2, and then insert my equation. for motion with acceleration or non-uniform acceleration, using a polynomial function will allow you to analyze the change in acceleration as a function of time as well. Okay. Thanks for watching. See you next time.